So, first up for this sequence of lightning talks this afternoon, we have Aman Singh from Mercari and Sho Akiyama, also from Mercari, to talk about fine-tuned SigLIP. I will let you explain.
Hello, everyone. I'm Sho Akiyama from the ALM team at Mercari. I'm an engineer, and also we have Aman Singh here. He's from the ML platform team at Mercari. He's also an engineer. We're here to talk about the how we fine-tuned a multimodal model called SigLIP for improving our image-based recommendations for our marketplace. And as an agenda for this quick lightning talk, we're gonna do a quick introduction what the marketplace is, and then we're gonna go into like how we fine-tuned the model and how we deployed the model, care of Aman, and then what's next. For the introduction, yes, a bit about our platform. Mercari is basically, we're a C2C marketplace app where users can buy and sell their own stuff. And yeah, I guess like you've also seen some of the other talks with the Mercari people as well. So yeah, we're not going to dive into detail there. And for the project background, basically, so in our item detail page, it's basically like when you open an item, for example, you would get recommendations, right? And one of the recommendations is called similar looks. So it's basically showing visually similar items in a grid like this, for example. So if you're looking at a ring, for example, with this brand called Ete, which is a Japanese brand, I think. It would show like similar looking items based on the model. And we would use an old like pre-trained model called MobileNet at the time. And it was pretty good. It was showing these types of items. But we thought, what if we fine-tuned like a multimodal model and used the image vision model there to try improving this? And when we did the online evaluations with an A/B test, we found out that, yeah, it did increase the tap rate by 1.5x. And also even the purchase count for the item detail page by 14%. So it was pretty solid. And yeah, basically this is how it looked like before. So many different teams would use different models for their own use cases. Some of them are similar, like image similarity, for example. And for this case, basically the recommendation team was using MobileNet, which is just the pre-trained version. And then we tried using we called it internally like Mercari SigLIP, because it was trained on like image and text pairs from our listings, basically. And then when we fine-tuned it, yeah, it was pretty straightforward. We were using mostly the GCP ecosystem. So it was, we were using Vertex AI pipelines for it. And even the ETL was done through BigQuery. And then, yeah, basically we just Dockerized both the fine-tuning, the training images, and also the evaluation images. And then we also monitored with weights and biases. Which you could easily visualize like how the training loss has been happening, for example. And even the evaluation part, like both for the offline quantitative and qualitative evaluation. So even the spreadsheet generation, it was all automated. And next on the deployment, here is Aman to speak about it.
Thank you, Sho, for the quick introduction. So for the deployment process, like we are using Triton Inference Server. And for those who are not aware, like Triton Inference Server is an open source tool provided by NVIDIA for like easier deployment of machine learning models. So currently we are running our models on L4 GPUs in GKE. And the reason is because like we want like the optimized performance and efficiency. And one of the main point that it does is like it like supports multiple model formats like ONNX, TensorRT, PyTorch. And yeah, it also enables us to like add custom code on top of our models. So basically like the custom code also runs inside the container. So that's also a benefit for us. And other thing is like the custom code can run on CPU, whether like the model is running on GPU. So that increases our resource usage. Yeah. And this is the pipeline. So whenever like a listing happens in Mercari, the image comes to like the Triton server, and the pre-processing basically like sets the image proper to like for the SigLIP model, and the image goes to like the SigLIP Vision model, and there we create the embeddings for post-processing. In the post-processing, we basically use PCA for dimension reduction, and then the final embeddings are like sent for image search, for indexing, and for similarity. Yeah, this is our like the whole architecture. If you want to take a look, like you can. Yeah, this is the project background.
Yes, just finishing up. So yeah, that's what we use for the
Promptly,
front
please.
background. But yeah, thank you so much. And yeah, we wouldn't have done it without all these open source software. So we really thank everyone for this. And yeah, thank you so much. And yeah, this is the team. And thank you so much for listening. See you. Come to our booth, by the way.
So